Hello students, welcome back. Let us resume our discussion in section 2. Previously we went through examples 2.1 and 2.2. And please remember, they were both systems of linear equation problems. Let's go to 2.3 and here's the problem. Stop the playback and read through, and then try to set up the problem on your own. Well, did you get it done? Or do you need help? Let's see, how does it go? A motorboat heads upstream a distance of 24 miles on a river whose current is running at constantly 3 miles per hour. The trip up and back takes 6 hours. Assuming that the motorboat maintains a constant speed relative to the water, what is its speed? Well, that's the problem. Okay, how do you set it up? Let's do one step at a time. Eventually, this problem is looking for this. What is v, where v is the speed of the boat? And then clearly the speed of the boats must exceed 3 miles per hour. Otherwise, it cannot go upstream at all. And then the net speed going up will be less than this v. By how much? By 3 miles per hour. The water is running constantly at 3 miles per hour. In order to go up, the speed of the boat must be faster than 3 miles per hour. If it is precisely 3, then it's not going to move at all. It's going to be faster. And compared with the original speed of the boat, you have to subtract by 3 because that's the speed of the water itself. Now, going downstream, it's the opposite. You have to add 3, and going downstream is faster. Okay, that's something we have. What else do we have? The trip up and back takes 6 hours. Okay, all right. So clearly we have this. X plus y is 6, assuming that x and y are the times. Okay, that's my x, and then y is the time for moving downstream. And then x plus y add up to 6. That much is clear. Okay, all right. Now, what else do we have? Somehow we have to get v involved, right? Let's scrutinize the first equation. X plus y equals to 6. That much is certain. Trip up and back takes 6 hours. That much is certain. And then x and y should not be the same. X should take longer because trip up, we are moving slower. Trip down, you are moving faster. And how are they related to the distance of 24 miles? Any idea? Okay, let me give you a hint. Distance is speed times time. Or you can write speed is distance over time. But in any case, yeah, this is going to be a bit more convenient. So distance is 24 miles. And consider this as speed times time. And time is going to be x and y. Going up, it is x. Going down, it is y. So you can write like this. Distance 24 is speed going up times x. X is the time for moving upstream. And then by the very same idea, you're going to get this. The speed of moving downstream times y. They're both 24 miles. Now, what is the speed upstream and speed downstream in relation to the speed of the boat itself? If you answer that, then you're going to get the setup. What is it? Speed moving upstream, you have to subtract 3. Speed moving downstream, you have to add 3. Now I don't need this one anymore. Equation number 1, number 2, number 3, with 3 variables, x, y, and v. The setup is complete. Are you agree? I mean, do you agree? So setup is complete. Now let's solve this system. How do you solve the system of nonlinear equations? Well, it's nonlinear, so elimination probably will not work. So we'll have to use substitution. And also, the problem is asking for the speed. So it's going to be better if you express everything in terms of speed. So in that sense, let's express x in terms of v and y also in terms of v. So if you solve for x from the second equation, you're going to get x is 24 divided by v minus 3. Do you see that? Likewise, from this third equation, you're going to get 24 divided by v plus 3. Flipping this speed to the other side. Now that we have x and y solved with respect to v, substitute both of them into the first equation. What do you get? In place of x, we get 24 divided by v minus 3. And then instead of y, we get 24 over v plus 3, and that adds up to 6. And what do we have? We have an equation that we went through in lesson 1. Remember this? In lesson 1, we went through this kind of problems. How to solve this? Step 1, denominators. Step 2, parentheses. Step 3, like terms. Remember that? Denominators first. We have v minus 3 times v plus 3 here. I already revealed this, sorry. V minus 3 here, v plus 3 there. So the LCD to multiply is v minus 3 times v plus 3. So here, multiply by v minus 3, v plus 3, and then here, oops, v minus 3, v plus 3, and then you have to multiply the same thing here as well, v minus 3, v plus 3. Okay, we're almost there. How do you get this thing done? Well, look at this simplification. V minus 3 over v minus 3, that's going to go out so that we get 24 v plus 3. Do not break up the numerator. That's going to defeat the purpose. The purpose of step 1 is to remove the denominator. Remember that. And then v plus 3 go out. 24 v minus 3. And to the right hand side, what you have, if you fall out this v minus 3 times v plus 3, you're going to get v squared minus 9. As a matter of fact, I used a factorization formula. This one, as a matter of fact, a minus b, a plus b is a squared minus b squared. But if you FOIL out and simplify, you're going to get the same thing too. Okay, all right. Step 1 complete. No more denominator. Now step 2. Parentheses. Let's break those up. 24v plus 3 times 24 is 72. 24v minus 72, and then 6v squared minus 6 times 9, 54. Did I get it right? Okay, everybody will clearly see that 72, negative 72, they'll go out, and you're going to end up with 48v here, and this is 6v squared minus 54. Okay, flip everything over to the other side. 6v squared minus 48v minus 54. And then you can simplify this. Clearly, dividing everything by 6, you're going to get a harmonic equation. V squared minus 4v minus 8v, excuse me, minus 9 equals to 0. Okay, alright. You can easily factor this, right? V minus 9, v plus 1 equals to 0. So v is either 9 or v is negative 1. Which is right and which is wrong? Or are both of them correct? Well, we are looking at a speed of both. So negative speed or going backward, that doesn't make much sense, does it? It's got to be this one here. So the speed of the boat is 9 miles per hour. And then by plugging those into this one here and that one over there, you can find out the times as well. This problem did not ask you the time, but if you wanted, you could find those. So there goes a full solution, but as a matter of fact, we already have an answer key here. So here's the setup. Yeah, x plus y add up to 6. And then speed of the boat upstream is v minus 3, and the time is x. Speed of the boat downstream is v plus 3, and the times y, we get 24. So we have a system of 3 equations. The first one is linear, but the second and the third are nonlinear. We cannot use elimination because this is not a system of linear equations. Let's use substitution. And we are looking for v, so solving for v in the end is the best. So x is 24 over v minus 3, y is 24 plus v over 3, if you do that, if you solve. And then substitute those in, you get, well, this. 24v over v minus 3 plus 24 over v plus 3 equals to 6. And solving this, well, the typical technique we used to use in lesson 1. Step 1, denominator, so multiply by the LCD and simplify. And step 2, parentheses, yeah, here, parentheses, foiling out and then further breaking up. Take the like terms together, simplify further, factor, and then we have a nice solution, legitimate, and then something that doesn't make any sense. And from 9, negative 1 is impossible, and you can find out upstream and downstream times as well. It turns out 4 hours upstream and 2 hours downstream. Okay, that completes this problem, and I'll leave 2.4 to you, and let's say section 2 is complete.